Hello there, and welcome to Whispers of Science, where the mysteries of our universe unfold gently and knowledge finds its quiet rhythm. Tonight, we're embarking on a journey into one of nature's most elegant and invisible forces: magnetic fields, the unseen architects that have been shaping our planet for billions of years, guiding everything from the smallest compass needle to the grandest auroras dancing across polar skies. Before we begin our gentle exploration, I'd love to know where in the world you're listening from tonight and whether you can see any stars from where you are fitting. Isn't it that we're about to discuss the invisible threads that connect our planet to the cosmos, while each of us gazes up at that same vast skies from our own little corner of Earth? If this peaceful journey through planetary magnetism brings you comfort or curiosity, I'd be ever so grateful if you gave the video a like and perhaps subscribed it. Helps this quiet corner of science reach others who might need a moment of wonder after a long day. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does well, at least you'll drift off, knowing something beautiful about the invisible forces that cradle our world. So settle in, take a slow breath, and let's begin. Because somewhere in the space between atoms and galaxies, between the molten core beneath your feet and the solar wind streaming past your window, lies the gentle story of magnetism. Imagine for a moment that you could see magnetic fields the way you see light. Suddenly, the world around you would shimmer with invisible rivers of force flowing in graceful curves around every magnet, every electrical current, every spinning planet. These fields don't care about walls, or distance, or the vacuum of space. They simply exist, weaving through reality like silent music made visible. Our Earth, you see, is a giant magnet floating in space. Not the kind you stick on your refrigerator, but something far more subtle and infinitely more powerful deep beneath your feet. Roughly 2,900 kilometers down lies our planet's liquid iron core, spinning and churning in the darkness. This molten metal moves in vast currents, driven by the Earth's rotation and the slow cooling of our world's ancient heart. And as this conducting fluid flows, it creates something remarkable: a magnetic field that extends far beyond our atmosphere into the emptiness of space. This planetary magnetism isn't just a curious scientific fact, it's the reason you're here. The reason any of us are here listening to these words, breathing this air, existing at all. Because without Earth's magnetic field, our planet would be a very different place indeed: a cold, barren rock stripped of its atmosphere and scoured clean by radiation from space. The story begins 4.5 billion years ago, when our solar system was young and chaotic. Chunks of rock and metal crashed together in the darkness, slowly building the planets. We know today Earth was a hellish place, then a molten ball of rock constantly bombarded by asteroids and comets. But as our world grew larger, something interesting began to happen deep in its core. The heavy elements, iron and nickel, sank toward the center, while lighter materials rose toward the surface. This process, called differentiation, created the layered structure we see today. But more importantly, it concentrated vast amounts of liquid iron in Earth's core. And when that iron began to move, driven by the planet's rotation and convection currents, something magical happened. It became a dynamo. A dynamo, you see, is simply a device that converts motion into magnetism. When conducting material like liquid iron moves through a magnetic field. It generates electrical currents, and those currents create their own magnetic fields, which can strengthen the original field. It's a beautiful feedback loop. Motion creates magnetism, which influences motion, which creates more magnetism, and so on, like a cosmic dance that's been spinning for billions of years. But Earth's magnetic field isn't just sitting there quietly, it's dynamic, constantly changing strength and direction on timescales from seconds to millions of years. If you could watch our planet's magnetism over geological time, you'd see it pulse and flicker, sometimes growing strong enough to deflect the harshest solar storms, sometimes weakening until compasses spin wildly searching for true north. Every few 100,000 years, something extraordinary happens. Our magnetic field decides to flip completely north and becomes south, south becomes north. And for a brief moment in geological terms, maybe a few thousand years, the field weakens dramatically during these reversals. Compasses would point in random directions, and our planet becomes more vulnerable to cosmic radiation. It's happened hundreds of times in Earth's history, leaving a record in ancient rocks, like chapters in a very long book. You might wonder how we know any of this after all. You can't exactly dig down to the core and take a look, but the Earth keeps its own records. When volcanic rocks cool, they lock in the direction of the magnetic field. At that moment, like tiny frozen compasses scattered across the globe by studying these magnetic signatures. In rocks of different ages, scientists can trace the history of our planet's magnetic field stretching back millions of years. What they've discovered is remarkable. Our magnetic field has been our planet's invisible guardian, shielding us from the worst that space can throw at us. The sun you see isn't just a gentle source of light and warmth. It's also constantly streaming charged particles into space, a solar wind that would strip away our atmosphere if it weren't for the magnetic field deflecting most of it safely around our planet. Without this protection, Earth might have ended up like Mars, which lost most of its magnetic field billions of years ago, and with it much of its atmosphere. What was once a world with flowing water and perhaps life became the cold, dry desert. We see today it's a sobering reminder of just how precious and fragile our magnetic shield really is. But the influence of Earth's magnetic field extends far beyond protection from space weather. It shapes the very structure of our planet's outer layers. The magnetosphere, that invisible bubble of magnetic influence that surrounds our world, creates a complex dance with charged particles from space. Some of these particles get trapped in radiation belts, while others spiral down toward the poles, creating the aurora. Those curtains of green and blue light that shimmer across northern and southern skies. These aurora aren't just beautiful, they're visible proof of our planet's magnetic field at work. When solar particles collide with atoms in our upper atmosphere, they release energy as light, painting the sky in colors that have inspired countless stories and legends. The ancient Norse called them the bridge between earth and heaven. The Inuit saw dancing spirits of the dead in their shifting patterns. But we now know there's something even more wonderful. The breath of our planet made luminous. The magnetic field also plays a role in navigation, not just for human explorers with their compasses, but for countless animals that have evolved to sense Earth's magnetism. Sea turtles use it to navigate across vast oceans. Birds follow magnetic highways during their migrations, and even bacteria contain tiny magnetic crystals that help them orient themselves in their microscopic world. It's as if the entire planet is singing a magnetic song that life has learned to hear and follow. Understanding Earth's magnetic field has become crucial as we face changes in our modern world. The field has been weakening over the past few centuries, dropping about 10% in strength since records began. Some scientists worry we might be approaching another magnetic reversal, though predicting exactly when such an event might occur remains beyond our current abilities. What we do know is that our increasingly electronic civilization has become vulnerable to magnetic storms that can disrupt satellites' power grids and communication systems. The story of Earth's magnetism is also deeply connected to the story of life itself. Some researchers believe that magnetic fields might have played a role in protecting early life from radiation, allowing complex organisms to evolve in the safety of our planet's magnetic embrace. Others suggest that the minerals formed by ancient magnetic processes provided the raw materials that life needed to get started. As we look to the future, understanding planetary magnetism becomes even more important. As we explore other worlds, we search for magnetic fields around distant planets, knowing they might indicate conditions suitable for life. The detection of magnetic fields around exoplanets is still in its infancy, but it represents one of our best hopes for finding worlds that might harbor life as we know it. Our own magnetic field continues to be a source of wonder and discovery. New satellites monitor its every fluctuation, while deep Earth researchers try to understand the complex processes that sustain it. We're learning that the geodynamo in Earth's core is far more complicated than early models suggested, with multiple layers of flow and complex interactions between the solid inner core and liquid outer core. The magnetic field also serves as a window into Earth's interior by studying how magnetic signals propagate through our planet. Scientists can map the structure deep below our feet, revealing hidden mountains and valleys on the core mantle boundary and tracking the slow convection currents that drive plate tectonics. It's like having X ray vision that can peer all the way to the center of our world. But perhaps most remarkably, Earth's magnetic field connects us to the cosmos in ways we're only beginning to understand. It couples our planet to the solar wind, creating a vast system that extends far beyond our atmosphere. This magnetosphere interacts with cosmic rays, charged particles from distant stars, and supernovas shaping the radiation environment that has influenced the evolution of life for billions of years. As we continue our journey through the whispers of science, we'll explore how these magnetic fields work their quiet magic, how they've shaped not just our planet, but the very possibility of life itself, how they guide the migration of animals and influence the chemistry of our atmosphere, and how understanding them might help us protect our technological civilization from the invisible storms that rage through space. The story of magnetism is ultimately a story about connection, the connection between Earth's deep interior and its surface, between our planet and its star, between the invisible and the visible, between the ancient past and the uncertain future. It's a reminder that we live in a universe where forces we cannot see or touch shape every moment of our existence. Tonight, as you drift towards sleep, remember that you are cradled not just by gravity, but by magnetism, an invisible embrace that has protected our world for billions of years. a gentle force that guides birds across continents and paints lights across polar skies, the same force that makes your compass point north and shields you from the harsh radiation of space. In our next gentle exploration, we'll delve deeper into how this planetary magnetism actually works, the elegant dance of liquid iron in Earth's core that generates our protective field, and how this ancient process continues to evolve, shaping our world in ways both subtle and profound. Until then, sleep while knowing that you're safely wrapped in Earth's magnetic cocoon, floating through space on a planet that hums with invisible forces of protection and wonder. The whispers of science continue, and there are more mysteries waiting in the gentle darkness of discovery. More stories about the invisible forces that make our existence possible. More reasons to marvel at the elegant complexity of the world we call home. Sweet dreams, fellow traveler, in this magnificent magnetic universe. Deep beneath our feet, where sunlight has never touched and pressure would crush any living thing in an instant, something extraordinary is happening. In the swirling metallic heart of our planet, liquid iron flows in patterns more complex than any river, more graceful than any dance, and from this motion in the darkness emerges the invisible force that makes our world habitable. To understand how Earth generates its magnetic field, we must journey to a place no human has ever been and never will. The outer core, a shell of molten iron and nickel that begins about 2,900 kilometers below your feet and extends nearly halfway to the center of our planet. Here, temperatures soar to over 4,000 degrees Celsius, hot enough to melt copper. Yet the immense pressure keeps this metal in a liquid state, flowing and churning in the eternal darkness. Imagine, if you will, a sphere of liquid metal larger than the planet Mars, spinning within our Earth, driven by forces that have operated without pause for over 4 billion years. This isn't the gentle flow of honey from a jar, but a turbulent, chaotic motion where currents of molten iron race through the darkness at speeds that would make a hurricane seem sluggish. Vast plumes of hot metal rise toward the surface, while cooler currents sink back toward the center, creating a three-dimensional tapestry of motion that defies easy description. But motion alone doesn't create magnetism. There must be something more, and that something is the Coriolis effect, the same force that causes hurricanes to spin and makes water swirl down a drain as our planet rotates every 24 hours. It drags the liquid iron core along with it, but the core spins slightly differently than the solid mantle above, creating a shearing motion that twists and stretches the flowing metal into complex patterns. Now, here's where the magic truly begins. When liquid iron moves through even the faintest magnetic field, it generates electrical currents, much like a wire moving through the magnetic field of a generator. These currents flowing through the conducting metal create their own magnetic fields, which can either strengthen or weaken the original field. It's a delicate balance, a cosmic feedback loop, where magnetism begets motion, and motion begets magnetism. Scientists call this process the geodynamo, and it's one of nature's most elegant, self-sustaining systems. The Earth's rotation provides the energy. The liquid iron provides the conducting medium, and the geometry of the core provides the structure needed to amplify weak magnetic signals into the powerful field that surrounds our planet. It's like having a generator the size of Mars spinning in the center of our world, powered by the rotation of the planet itself. But the geodynamo isn't just a simple machine humming along, unchanged for billions of years. It's a complex, chaotic system that can shift and fluctuate in ways that still puzzle scientists. Sometimes the dynamo runs smoothly, generating a stable magnetic field with north and south poles roughly aligned with the Earth's rotation axis. Other times, it becomes unstable, wobbling and weakening until the magnetic poles wander far from their usual positions. During these periods of instability, something remarkable can occur. The magnetic field can collapse almost entirely before rebuilding itself with opposite polarity. What was once magnetic north becomes magnetic south, and vice versa. These reversals aren't rare curiosities. They've happened hundreds of times in Earth's history, roughly every few 100,000 years, though the timing is far from regular. The last reversal occurred about 780,000 years ago during what geologists call the Brunhes-Matuyama reversal. If you could have witnessed this event, you would have seen compass needles spinning wildly as the magnetic field weakened and shifted. The aurora would have appeared at strange latitudes, painting the sky in unusual places. As charged particles from space found new pathways through the weakened magnetic barrier, these reversals leave their signature in the geological record. When volcanic rocks cool, they lock in the direction of the magnetic field like tiny fossil compasses. By studying these magnetic signatures in rocks of different ages, scientists have mapped the history of Earth's magnetic field, stretching back millions of years, revealing a complex pattern of stability and change that reflects the ever shifting dynamics of the core. The magnetic field we experience today isn't perfectly aligned with Earth's rotation axis. Magnetic north currently lies in northern Canada, about 400 kilometers from the geographic North Pole, and it's constantly moving at a rate of about 50 kilometers per year. This wandering reflects the complex motions in the core where the magnetic field is generated. It's as if the dynamo deep below has its own sense of direction that doesn't quite match the planet's spin. Understanding how the geodynamo works has profound implications for our future. The magnetic field has been weakening steadily over the past few centuries, dropping about 10% in strength since reliable measurements began. Some scientists wonder if we're witnessing the early stages of another reversal, though predicting such events remains beyond our current capabilities. The magnetic field operates on timescales that dwarf human experience, and its behavior remains partly mysterious. What we do know is that the dynamo requires certain conditions to operate effectively. The core must remain liquid, which depends on the planet retaining enough internal heat. The rotation must be fast enough to create the necessary Coriolis effects, and the geometry of the core must allow for the complex flow patterns that sustain the magnetic field. Any significant change in these conditions could alter or even shut down the dynamo entirely. This is precisely what appears to have happened to Mars. Billions of years ago, that planet once had a magnetic field generated by its own dynamo. But as Mars cooled more rapidly than Earth, its core solidified and the dynamo ceased operating without magnetic protection. The solar wind gradually stripped away most of Mars' atmosphere, leaving behind the cold, thin air. We see today it's a sobering reminder of how crucial the dynamo is for maintaining a habitable planet. The study of planetary dynamos has become a field of intense research as scientists try to understand not just how Earth's magnetic field works, but how magnetic fields operate on other worlds. Venus rotates too slowly to generate a strong dynamo. Mercury has a weak magnetic field that suggests a partially molten core, while the gas giants Jupiter and Saturn have powerful magnetic fields generated by the motion of metallic hydrogen. In their interiors, each world tells a different story about how magnetism can arise and evolve. Closer to home, the moon provides another piece of the puzzle. Our satellite once had a magnetic field of its own, as evidenced by magnetized rocks brought back by Apollo astronauts. But the lunar dynamo shut down billions of years ago when the moon's core cooled and solidified without the protection of a magnetic field. The lunar surface has been bombarded by charged particles from space for eons, creating the radiation environment that future explorers will need to contend with. The Earth's dynamo also influences the structure of our planet in subtle ways. The magnetic field couples with the motion of the liquid core, creating torques that can slightly alter the length of our day. Over long periods, it also affects the transfer of heat from the core to the mantle, influencing the patterns of convection that drive plate tectonics in this way. The magnetic field is intimately connected to the geological processes that shape our planet's surface. Modern technology has given us unprecedented tools for studying the geodynamo satellites orbiting high above our atmosphere monitor every fluctuation in the magnetic field, while supercomputers simulate the complex fluid dynamics of the core. These simulations reveal a chaotic, beautiful system where magnetic field lines twist and reconnect in patterns reminiscent of solar flares or the aurora themselves. The magnetic field lines generated in the core don't simply point from north to south. They form complex loops and spirals that extend from the center of the Earth all the way out into space. Some field lines connect the core directly to the magnetosphere, while others loop back on themselves, creating regions of intense magnetic activity. These field lines are constantly moving, stretching, and reconnecting as the dynamo evolves. Perhaps most remarkably, the geodynamo appears to be self-regulating when the magnetic field grows too strong. It can suppress the very motions that generate it, causing the field to weaken conversely when the field becomes too weak. The motions in the core can amplify it back to strength. This natural feedback mechanism has kept Earth's magnetic fields operating for billions of years, despite the chaotic nature of the underlying dynamo. The energy that powers this magnificent system comes ultimately from the cooling of the planet. As Earth slowly loses heat to space, the core contracts and crystallizes, releasing gravitational energy that drives convection currents in the liquid outer core. This process will continue for billions of years more, though eventually, as our planet cools, the dynamo will weaken and perhaps cease altogether. But that distant future is unimaginably far away. For now, the dynamo continues its ancient work, spinning liquid iron into invisible threads of magnetic force that reach out from the core through the mantle, through the crust, through the atmosphere, and into the vacuum of space, creating the protective bubble that makes life possible. As we drift deeper into our exploration of planetary magnetism, we begin to see how this invisible force shapes not just the physics of our world, but the very possibility of existence itself. The dynamo in Earth's core is more than just a geological curiosity. It's the beating heart of our planet's magnetic system, the source of the invisible rivers of force that guide compasses cradle aurora and shield us from the harsh radiation of space. The story of how liquid iron becomes planetary protection is one of the most elegant tales in all of science, a reminder that the most fundamental forces shaping our world often operate in darkness beyond our direct perception. Yet their effects ripple outward through every aspect of our existence, from the wandering of magnetic poles to the shimmering of northern lights, from the navigation of migrating birds to the protection of our technological civilization. Tomorrow we'll continue our gentle journey through the whispers of planetary magnetism, exploring how these invisible fields reach far beyond our planet to create the magnetosphere, that vast magnetic bubble in space where Earth's influence extends and where the solar wind meets its match. Until then, rest easy, knowing that deep beneath your feet, the ancient dynamo continues its work, spinning metal into magnetism, and magnetism into the invisible embrace that keeps our world safe. The magnetosphere, our planet's invisible fortress, extends far beyond the familiar blue marble we see in photographs, stretching out into space for tens of thousands of kilometers, like a vast teardrop shaped bubble, with Earth nestled safely inside. This invisible realm, where magnetic fields reign supreme, is where some of nature's most spectacular battles take place, fought not with swords or cannons, but with charged particles and invisible forces. Imagine, if you will, standing on the surface of the moon, looking back at the Earth. What you'd see with your eyes would be a beautiful blue and white sphere hanging in the darkness. But if you could see magnetic fields, the view would take your breath away. Earth would be surrounded by a shimmering cocoon of invisible force lines, stretching and bending in the solar wind like the most elegant sculpture ever created, constantly shifting and flowing as it meets the stream of particles from our star. This magnetosphere isn't just empty space with a few magnetic field lines scattered about. It's a complex dynamic region filled with trapped particles, electric currents, and phenomena that would seem like magic if we didn't understand the physics behind them. It's here in this invisible realm that the solar wind meets its match, where Earth's magnetic personality truly shines. The solar wind you see isn't the gentle breeze. Its name might suggest it's a supersonic stream of charged particles, mostly protons and electrons racing away from the sun at speeds of several hundred kilometers per second. This wind carries with it pieces of the sun's own magnetic field, creating a complex tapestry of forces that fills the entire solar system. When this wind encounters Earth's magnetic field, something remarkable happens. On the side facing the sun, the magnetosphere is compressed, like a bubble being squeezed. The boundary between Earth's magnetic domain and the solar wind, called the magnetopause, can be pushed as close as 60,000 kilometers from our planet's surface during intense solar storms. Meanwhile, on the night side of Earth, the magnetosphere stretches out into a long tail that extends beyond the orbit of the moon, creating an asymmetrical teardrop shape that's constantly rippling and shifting in the solar breeze. But the magnetosphere isn't just a passive barrier deflecting the solar wind around our planet. It's an active participant in a cosmic dance that creates some of the most beautiful phenomena in nature when the solar wind carries magnetic field lines that point opposite to Earth's field. Something called magnetic reconnection can occur. It's like two rivers flowing in opposite directions, suddenly finding a way to merge, creating turbulence and energy release on a planetary scale. During these reconnection events, some of the solar wind's energy gets transferred into the magnetosphere, accelerating particles to incredible speeds and sending them spiraling along Earth's magnetic field lines toward the polar regions. This is how the aurora are born, not just as pretty lights in the sky, but as visible evidence of the ongoing interaction between our planet's magnetic field and the charged particle environment of space. The trapped particles in the magnetosphere don't just create aurora, they form distinct regions called radiation belts, discovered by explorer One America's first successful satellite in 1958. These belts, named after physicist James Van Allen, who interpreted the satellite's data, are like invisible donuts of high energy particles surrounding our planet. Sailors of space. These particles can be dangerous to astronauts and spacecraft electronics, but they also serve as a natural laboratory for studying plasma physics. Within the magnetosphere, particles can be accelerated to incredible energies, sometimes approaching the speed of light during magnetic storms. These particles can be injected deeper into the magnetosphere, creating enhanced radiation belts that can persist for months. It's a reminder that space around Earth isn't the empty vacuum we might imagine, but a dynamic environment filled with invisible activity. The structure of the magnetosphere varies dramatically, depending on conditions in the solar wind. During quiet periods, it maintains a relatively stable teardrop shape, but when the sun becomes active, launching coronal mass ejections or high-speed solar wind streams, the magnetosphere can be compressed, squeezed, and stretched in ways that create spectacular space weather events. These space weather phenomena aren't just academic curiosities. They have real effects on our technological civilization. When the magnetosphere is disturbed by solar activity, it can induce electrical currents in power lines, potentially causing blackouts, disrupt satellite communications, and create navigation errors in GPS systems. The same magnetic field that protects us from space radiation can also couple that radiation into our technological infrastructure in unexpected ways. The aurora themselves tell the story of this cosmic interaction in exquisite detail. The green curtains we most commonly see are created when energetic particles collide with oxygen atoms about 100 kilometers above the surface. The rarer red aurora occur higher up, where the atmosphere is thinner and oxygen atoms have more time to emit their characteristic red glow. Blue and purple aurora come from nitrogen, each color a signature of different atmospheric gases responding to the rain of particles from space. But aurora aren't just pretty light shows. They're diagnostic tools that reveal the hidden workings of the magnetosphere. The patterns and movements of auroral displays map the invisible structure of magnetic field lines and the flow of particles along them. Scientists can read the aurora like a book written in light learning about magnetic substorms, particle acceleration, and the coupling between solar wind and magnetosphere. Indigenous peoples around the world have long recognized the aurora as something special. The Sami people of northern Scandinavia called them Revantula, the firefox fires, believing they were created by a magical firefox running so fast across the snow that its tail swept up snowflakes which sparkled in the moonlight. The Inuit had many names for aurora, including Aksarniet, the dancers, and saw in their movements the spirits of those who had died in childbirth or by violence. These cultural interpretations, while different from our scientific understanding, capture something profound about the aurora. They are indeed dancers, cosmic performers, putting on a show that connects Earth to the heavens, in the most literal sense. When you watch the aurora, you're seeing the intersection of terrestrial and cosmic forces, made visible the marriage of Earth's magnetic field with the charged particle environment of interplanetary space. The magnetosphere also plays a crucial role in protecting our atmosphere from erosion by the solar wind. Without this magnetic shield, charged particles from the sun would gradually strip away our air, much as they appear to have done to Mars over billions of years. The magnetic field channels most of the solar wind around our planet, like water flowing around a stone in a stream, allowing only a small fraction of particles to penetrate to the upper atmosphere. This protective function becomes even more important during periods of high solar activity when coronal mass ejections can carry billions of tons of solar material toward Earth at speeds exceeding 1,000 kilometers per second. These events can compress the magnetosphere so dramatically that aurora appear at latitudes where they're normally never seen evidence of how far the magnetic protection has been pushed back toward our planet. Studying the magnetosphere requires a fleet of spacecraft positioned throughout this invisible domain. Missions like Cluster Themis and the Van Allen probes have revealed the magnetosphere to be far more complex and dynamic than early theories suggested. It's filled with plasma waves, magnetic bubbles, and particle populations that ebb and flow with the rhythm of solar activity, like a vast three-dimensional ocean of electromagnetic phenomena. The magnetosphere also extends Earth's influence far beyond our planet's physical boundaries. It's in a real sense the outermost layer of our world, as much a part of Earth as the atmosphere or oceans. This magnetic domain carves out a cavity in the solar wind, creating a region where Earth's magnetic field dominates over interplanetary magnetic fields. It's our planet's way of claiming a piece of space as its own. Within this magnetospheric cavity, conditions can be quite different from the surrounding interplanetary medium. Temperatures can be higher, particle densities lower, and magnetic field configurations far more complex. It's like having a room with its own weather system embedded within the larger environment of the solar system. The tail of the magnetosphere that extends away from the sun is a particularly dynamic region. Here, magnetic field lines can snap and reconnect like rubber bands, releasing enormous amounts of energy in events called magnetospheric substorms. These substorms can inject particles deep into the inner magnetosphere, creating enhanced aurora and increased radiation levels around Earth. Understanding magnetospheric physics has become crucial as we venture further into space. Future missions to the moon and Mars will take astronauts beyond the protection of Earth's magnetic field, exposing them to the full force of solar and cosmic radiation. The experience gained from studying our own magnetosphere provides essential knowledge for protecting human explorers in the hostile environment of interplanetary space. The magnetosphere is also a window into conditions throughout the solar system. Other planets with magnetic fields, Jupiter, Saturn, Uranus, and Neptune, have their own magnetospheres, each with unique characteristics that reflect the properties of their magnetic fields and their interaction with the solar wind. Studying these diverse magnetic environments helps us understand the fundamental physics of how magnetic fields interact with flowing plasmas. Perhaps most remarkably, the magnetosphere connects us directly to the sun through invisible threads of magnetic force. During certain conditions, magnetic field lines in the magnetosphere can connect directly to solar magnetic field lines, creating a pathway for energy and particles to flow from our star to our planet. It's as if Earth and Sun are connected by invisible wires, carrying the news of solar activity directly to our magnetic doorstep. As our exploration of planetary magnetism continues, we begin to see how these invisible fields create not just protection, but connection linking our world to the broader electromagnetic environment of the solar system. The magnetosphere isn't just Earth's shield, it's also Earth's antenna, constantly receiving and responding to the electromagnetic signals that fill interplanetary space. The story of Earth's magnetic field is ultimately a story about boundaries and bridges. The boundary between our planet and space, the bridge between terrestrial and cosmic phenomena, the invisible connections that link Earth to Sun and make our world part of a much larger electromagnetic system that spans the entire solar system and beyond. As we prepare to continue our gentle journey through the whispers of science, remember that you're not just sitting on the surface of a planet, you're within a vast magnetic bubble that extends your world far into space. Every breath you take, every heartbeat, every thought occurs within this invisible electromagnetic embrace that has been sheltering life on Earth for billions of years. Tomorrow we'll explore how this planetary magnetism influences life itself, from the bacteria that navigate using magnetic crystals to the great migrations that span continents guided by invisible magnetic highways. Until then, rest peacefully knowing that Earth's magnetic field continues its ancient vigil, stretching out into the darkness of space like invisible arms holding back the harsh radiation that would otherwise make our blue planet as barren as the moon. The whispers of science grow softer now, but the story continues in the gentle darkness where magnetic field lines weave their protective spell around our precious world. Sweet dreams, fellow traveler, in this magnificent magnetic universe where invisible forces create visible wonders, and where the dance between Earth and space continues through every peaceful night. Throughout the history of life on our planet, countless creatures have discovered something remarkable about the world around them. It hums with invisible guidance, whispering directions through forces they cannot see but somehow feel. From the tiniest magnetotactic bacteria swimming in pond water to the great whales crossing ocean basins, life has learned to listen to Earth's magnetic song, turning our planet's invisible field into nature's most ancient navigation system. Imagine, if you will, a sea turtle hatchling no bigger than your palm emerging from its sandy nest on a moonlit beach. For the first time in its life, this tiny creature faces the vast darkness of the ocean with no map, no compass, no GPS device, yet somehow it knows exactly where to go, guided by magnetic field lines, as reliable as any highway. It will swim thousands of kilometers, following invisible pathways that have guided its ancestors for millions of years. This remarkable ability, called magnetoreception, is far more common in the natural world than we once believed. It's as if life discovered early in its evolution that the planet itself could serve as a guide, providing direction and location information anywhere on Earth's surface, from the deepest ocean trenches to the highest mountain peaks. The magnetic field offers a consistent reference frame that never fails, never needs batteries, and never loses signal. The story begins with the smallest magnetic navigators, bacteria so tiny that millions could fit on the head of a pin. These microscopic organisms contain chains of magnetite crystals called magnetosomes that act like internal compass needles, aligning the bacteria with Earth's magnetic field lines in northern hemisphere waters. These bacteria use their magnetic sense to swim downward, following field lines toward the nutrient rich sediments at the bottom of lakes and ponds. But bacteria are just the beginning as life evolved into more complex forms. The magnetic sense became increasingly sophisticated. Birds developed clusters of magnetic crystals in their beaks and possibly in specialized cells behind their eyes. Sea turtles carry magnetic maps in their brains that allow them to navigate across entire ocean basins. And even some mammals appear to use magnetic information for orientation, though the mechanisms remain partly mysterious. The great migrations that have inspired humans for millennia are in many cases magnetic journeys. Arctic terns make the longest migration of any animal, flying from Arctic to Antarctic and back again each year, a round trip of over 70,000 kilometers. These remarkable birds use a combination of celestial cues and magnetic information to navigate across featureless oceans with precision that would impress any pilot. Salmon return to their natal streams after years in the open ocean, guided partly by their ability to recognize the unique magnetic signature of their birthplace. Each river system creates subtle variations in the local magnetic field, and young salmon appear to imprint on these magnetic fingerprints before heading to sea, allowing them to find their way home across thousands of kilometers of open water. Even more remarkably, some animals seem to see magnetic fields directly rather than just sensing their direction. Certain birds may have a form of magnetic vision where magnetic field lines appear as patterns of light or shadow overlaid on their normal sight. Imagine being able to see the invisible highways of magnetism stretching across the landscape like glowing pathways in the sky, guiding you unerringly toward your destination. The mechanisms behind these magnetic senses are still being unraveled by scientists, but they appear to involve several different approaches. Some animals use tiny crystals of magnetite or other magnetic minerals that act like biological compass needles. Others may use quantum effects in certain proteins where magnetic fields influence chemical reactions in ways that could provide directional information. In the case of migratory birds, researchers have discovered specialized cells in the retina that contain a protein called cryptochrome. When light hits these proteins, they may become sensitive to magnetic fields through quantum entanglement effects, creating a kind of magnetic overlay on the bird's vision. It's as if nature discovered quantum physics millions of years before humans and put it to practical use in navigation. The precision of biological magnetic navigation can be astounding. Loggerhead sea turtles, hatchlings, not only navigate toward the open ocean, but follow a specific migratory route around the North Atlantic Gyre, a journey that takes years to complete and brings them back to feeding grounds near their birthplace. This suggests they carry incredibly detailed magnetic maps that specify not just direction, but also location with remarkable accuracy. Lobsters demonstrate another fascinating aspect of magnetic navigation. They can maintain their direction even when transported in opaque containers to new locations, suggesting they continuously track their magnetic position like living GPS units. This ability allows them to navigate across the featureless ocean floor where visual landmarks are scarce and currents can be confusing. The magnetic sense isn't limited to long distance navigation. Many animals use it for local orientation. As well, mole rats living in underground tunnel systems use magnetic cues to maintain their sense of direction in the darkness. Even some domestic animals retain vestiges of magnetic sensitivity. Studies suggest that cattle and deer tend to align themselves with magnetic field lines when grazing and resting, though the purpose of this behavior remains unclear. Perhaps most intriguingly, humans may retain some magnetic sensitivity, though it's largely unconscious and poorly understood. Some studies suggest that people can sense magnetic north better than chance would predict, and there are reports of individuals who claim to have a strong sense of direction that might be related to magnetic sensitivity. But these abilities, if they exist, are far weaker than those found in other animals. The study of biological magnetism has revealed that magnetic navigation systems can be surprisingly fragile. Human generated electromagnetic fields from power lines, radio transmitters, and electronic devices can interfere with animal navigation systems. There are documented cases of migrating birds becoming disoriented near radio towers and whales stranding themselves in areas with unusual magnetic anomalies. Climate change adds another layer of complexity to magnetic navigation as ocean currents and atmospheric patterns shift the magnetic landscapes that animals use for navigation may change as well. Magnetic declination. The difference between magnetic north and true north varies across the planet and changes over time, potentially affecting the accuracy of biological compass systems. The implications extend beyond individual animals. Entire ecosystems depend on the successful migration and navigation of key species. When magnetic navigation systems are disrupted, it can affect breeding success, population distributions, and food web dynamics. The invisible threads of magnetism that guide animal movements are also threads that hold ecological communities together. Researchers studying magnetic navigation face unique challenges. How do you study something that's invisible and operating inside a living animal? Various approaches have been used, from attaching tiny magnets to animals to disrupt their magnetic sense, to using specially designed experimental chambers that can alter magnetic fields in controlled ways. Each study adds another piece to the puzzle of how life senses and uses Earth's magnetic field. The evolution of magnetic senses raises fascinating questions about the relationship between life and planetary processes. As Earth's magnetic field has changed over geological time through reversals and variations, how have biological navigation systems adapted? Some researchers suggest that magnetic navigation abilities may have evolved multiple times independently, as different lineages discovered the advantages of having a planetary positioning system. The precision required for magnetic navigation becomes even more impressive when we consider that Earth's magnetic field is relatively weak, about 50 times weaker than the field of a typical refrigerator magnet. Yet animals can detect variations in this field that are smaller than 1% of its strength. It's equivalent to detecting the whisper of a conversation in a noisy room and using that whisper to navigate across continents. Magnetic navigation also interacts with other senses in complex ways. Birds appear to use magnetic information in combination with celestial cues, the position of the sun and stars, to create robust navigation systems that work under various conditions. This multisensory approach provides redundancy, ensuring that animals can find their way, even when some sources of information are unavailable. The magnetic sense may also play a role in animal behavior beyond navigation. Some researchers suggest that magnetic fields might influence biological rhythms, sleep patterns, and even social behaviors. Though these connections remain speculative, the idea that life is fundamentally connected to planetary magnetic rhythms opens up intriguing possibilities for understanding biological processes. As our technology becomes increasingly sophisticated, we're beginning to create artificial systems inspired by biological magnetic navigation. Researchers are developing magnetic sensors based on biological principles and exploring how magnetic information might be used in robotics and autonomous vehicles. Nature's 4 billion year experiment with magnetic navigation offers valuable lessons for our own technological development. The story of magnetic navigation also highlights the interconnectedness of Earth systems. The magnetic field generated in the planet's core influences the behavior of bacteria in pond sediments, guides the migrations of birds across continents, and shapes the movements of marine life across ocean basins. It's a reminder that the Earth functions as an integrated system where processes in one domain can have effects that ripple through the entire biosphere. Perhaps most remarkably, magnetic navigation represents one of the few cases where life has learned to directly sense and use a fundamental physical force of nature. While we use tools to detect magnetic fields, these animals carry the sensors within their own bodies, evolved over millions of years, to interact directly with the planet's magnetic personality. The invisible highways of magnetism that crisscross our planet are more than just abstract field lines. They're the pathways that connect breeding grounds to feeding areas that guide young animals on their first journeys, that enable the great seasonal movements that have shaped ecosystems for millions of years. Without these magnetic roads, much of the natural world as we know it would cease to function. As we continue our gentle exploration of planetary magnetism, we begin to see how these invisible forces weave through every aspect of life on Earth, from the quantum mechanical processes in bird retinas to the epic migrations that span hemispheres. The magnetic field is not just Earth's shield against space radiation, but also nature's guidance system, written in the language of invisible force. Tomorrow we'll delve into how human civilization has learned to harness and understand these magnetic forces, from the ancient discovery of lodestone to the sophisticated magnetic technologies that power our modern world. Until then, rest peacefully, knowing that countless creatures around the globe are following their magnetic instincts through the darkness, guided by the same invisible force that has shepherded life across our planet for eons. The whispers of science grow quieter now as we prepare to drift into sleep. But the magnetic story continues all around us, in the navigation of night flying birds, the orientation of sleeping cattle, the movements of deep sea creatures following magnetic contours across the ocean floor. Even in rest, we remain cradled by the same magnetic embrace that guides the great migrations. Sweet dreams, fellow traveler in this world, where invisible forces write the map of life itself. From the moment our ancestors first noticed that certain stones could attract iron, humanity began a love affair with magnetism that would reshape our understanding of the world and eventually carry us into the modern age. The story of how we learned to harness Earth's invisible forces is one of curiosity, ingenuity, and the gradual realization that the planet beneath our feet was far more mysterious than anyone had imagined. Picture, if you will, an ancient Chinese navigator standing on the deck of a wooden ship, watching in wonder as a small piece of magnetized iron consistently pointed toward the same direction, no matter how the vessel turned or rolled in the waves. This simple observation, made over 2,000 years ago, would eventually revolutionize human exploration and connect distant civilizations across vast oceans. The magnetic compass, perhaps humanity's first practical use of Earth's magnetic field, transformed us from coastal wanderers into global explorers. But the compass was just the beginning. As centuries passed and human knowledge grew, we began to realize that magnetism wasn't just a curious property of certain stones, but a fundamental force woven into the very fabric of reality. The invisible field that guided our compasses was the same force that could make sparks jump across gaps, that could turn wheels and generate the mysterious energy we called electricity. In the quiet laboratories of 18th and 19th century scientists, magnetism began to reveal its deeper secrets. Hans Christian Ørsted discovered that electric currents could deflect compass needles, while Michael Faraday showed that moving magnets could generate electricity. These weren't just academic curiosities, they were glimpses into a unified force that would eventually power our entire civilization. The same planetary magnetism that guided migrating birds would one day light our cities and carry our voices across continents. The development of electromagnetic theory in the 19th century marked a turning point in human understanding. James Clerk Maxwell's elegant equations revealed that electricity and magnetism were two faces of the same phenomenon, that light itself was an electromagnetic wave, and that the invisible forces surrounding us were far more fundamental than anyone had suspected. Suddenly, the magnetic field that had quietly guided human navigation for millennia became the key to unlocking entirely new forms of technology. Edison's power stations and Tesla's alternating current systems were built on principles derived from our growing understanding of magnetism. The generators that produced electricity relied on the same basic principle that creates Earth's magnetic field. Moving conductors through magnetic fields generate electrical currents. In a sense, every electric motor and generator is a miniature version of the geodynamo spinning in Earth's core, converting motion into electromagnetic energy. The 20th century saw an explosion of magnetic technologies that would have seemed like magic to earlier generations. Radio waves, those invisible carriers of information, are electromagnetic phenomena that propagate through the same field that guides compass needles. When Marconi sent the first wireless signals across the Atlantic, he was using Earth's magnetic field as part of a vast communication system that spanned the globe. Magnetic recording technology revolutionized how we store and share information. The same principles that allow magnetotactic bacteria to orient themselves in Earth's field were adapted to create magnetic tape, hard drives, and credit card strips. We learned to encode music, movies, and data as patterns of magnetization, turning the invisible force that shapes our planet into a medium for preserving human knowledge and creativity. Modern navigation systems represent the culmination of thousands of years of magnetic technology development. While GPS satellites use radio signals rather than magnetic fields directly, they rely on atomic clocks that are kept stable using magnetic principles, and the entire system must account for the effects of Earth's magnetic field on radio wave propagation. Even in our satellite age, we remain dependent on the magnetic forces that have guided travelers since ancient times. Skates. The study of paleomagnetism, the magnetic field frozen in ancient rocks, has revealed Earth's history in ways that would astound our ancestors. By analyzing the magnetic signatures preserved in volcanic rocks and sediments, scientists can track the wandering of continents, the timing of volcanic eruptions, and the behavior of Earth's magnetic field over millions of years. The invisible force that once seemed mysterious and unpredictable now serves as a detailed record of our planet's past. Medical applications of magnetism have opened entirely new frontiers in diagnosis and treatment. Magnetic resonance imaging uses powerful magnetic fields to peer inside the human body without surgery, revealing the soft tissues and organs that X rays cannot show. The same force that guides migrating animals now helps doctors diagnose diseases and monitor the healing process. In a beautiful symmetry, the magnetic field that protects life on Earth has become a tool for preserving human health. The development of superconducting magnets has pushed magnetic technology into realms that seem almost supernatural. These devices can levitate trains, confine fusion reactions, and create magnetic fields thousands of times stronger than Earth's own field. Yet they all rely on the same fundamental principles that create the aurora and guide the compass needle. We've learned to amplify and control the invisible forces that surround us, turning them into tools for transportation, energy production, and scientific research. Magnetic data storage continues to evolve at a breathtaking pace. Modern hard drives can store terabytes of information in magnetic domains smaller than viruses, each one a tiny magnet that can be flipped between north and south orientations to represent digital data. The same binary language of magnetic polarity that records Earth's field reversals in ancient rocks now stores our photos, documents, and digital memories. The search for room temperature superconductors represents one of the holy grails of magnetic technology. If successful, this research could lead to lossless power transmission, magnetically levitated vehicles, and computers that operate without generating heat. The economic and environmental implications would be staggering, potentially transforming how we generate, distribute, and use energy on a global scale. Space exploration has given us new perspectives on planetary magnetism and its technological applications. Spacecraft use magnetometers to study the magnetic fields of other worlds, revealing the hidden structures of planets and moons throughout the solar system. These same instruments, descendants of the simple compass, now serve as our eyes and ears for understanding magnetic environments in the far reaches of space. The development of magnetic shielding technology has become crucial as our electronic civilization grows increasingly complex. Sensitive equipment must be protected from magnetic interference, while magnetic fields are also used to contain dangerous particles in fusion reactors and particle accelerators. We've learned to manipulate magnetism with extraordinary precision, creating fields that can trap individual atoms or deflect cosmic rays. Magnetic sensors have become so sensitive that they can detect the tiny magnetic fields generated by neural activity in the brain. Magnetoencephalography allows researchers to monitor brain function in real time, mapping the electromagnetic patterns that accompany thought, emotion, and sensory processing. The magnetic field that once seemed purely external now reveals the electrical activity within our own minds. The emerging field of spintronics promises to revolutionize computing by using the magnetic properties of electrons rather than just their charge. This technology could lead to computers that consume far less power while operating much faster than current systems. Once again, the fundamental properties of magnetism are poised to transform human technology in ways we're only beginning to imagine. Climate science relies heavily on magnetic measurements to understand how Earth's systems interact over long time periods. Ice cores contain magnetic particles that record ancient atmospheric conditions, while sediment cores preserve magnetic signatures that reveal past climate changes. The magnetic field serves as both a driver of climate through its interaction with cosmic rays and as a recorder of climate history through its influence on sediment deposition. The study of biomagnetic fields has revealed that living organisms generate their own weak magnetic signatures. The human heart produces measurable magnetic fields that can be detected by sensitive instruments, providing new ways to monitor cardiac health. Even the brain generates magnetic fields that reflect neural activity, opening possibilities for non invasive diagnosis and treatment of neurological conditions. Magnetic levitation technology continues to push the boundaries of transportation and manufacturing. Maglev trains glide above their tracks suspended by magnetic fields, eliminating friction and allowing for speeds approaching those of aircraft. In manufacturing, magnetic levitation enables the production of ultra pure materials by eliminating contact with container walls, leading to advances in everything from semiconductor fabrication to pharmaceutical production. The development of magnetic metamaterials has created artificial structures with magnetic properties that don't exist in nature. These engineered materials can bend magnetic fields in unusual ways, potentially leading to magnetic cloaking devices that could hide objects from magnetic detection. The same creativity that allows us to understand Earth's natural magnetism now enables us to create entirely new forms of magnetic behavior. Quantum magnetism represents the frontier where our understanding of magnetism meets the strange world of quantum mechanics. Researchers are exploring how magnetic fields behave at the quantum scale, leading to discoveries that could revolutionize computing, sensing, and energy storage. The invisible force that guides compass needles operates according to quantum principles that we're only beginning to understand and harness. As we look toward the future, magnetic technology continues to evolve in directions that would amaze our ancestors. From quantum computers that use magnetic fields to perform calculations, to fusion reactors that use magnetism to contain stellar temperatures, we're constantly finding new ways to harness the force that has shaped our planet for billions of years. The story of human magnetic technology is ultimately a story of partnership with the planet itself. We've learned to work with the same forces that create the aurora, guide migrating animals, and protect us from space radiation. Every magnetic device we create is a collaboration with the fundamental forces of nature, a testament to our growing understanding of the invisible architecture that surrounds us. Perhaps most remarkably, our magnetic technologies have allowed us to extend our influence far beyond Earth's surface. Spacecraft use magnetic fields for navigation and attitude control, while magnetic sails could one day propel vessels between the stars using the solar wind. The same force that once confined human exploration to the Earth's surface may eventually carry us to distant worlds. As our exploration of planetary magnetism continues, we see how the invisible forces that shape our world have become partners in human progress, tools for understanding the universe, and gateways to technologies we're only beginning to imagine. The whispers of science grow softer now as we prepare to continue our journey into the gentle mysteries that surround us. But the magnetic story continues to unfold, connecting past and future in invisible threads of force and wonder. As our gentle journey through the realm of planetary magnetism draws toward its peaceful conclusion, we find ourselves standing at the edge of tomorrow, where the invisible forces that have shaped our world for billions of years continue to whisper secrets about the future. The magnetic field that cradles our planet, guides migrating creatures, and powers our technologies is still writing new chapters in the grand story of Earth and cosmos, chapters we're only just beginning to read. In laboratories around the world, scientists peer into the future of magnetism with instruments so sensitive they can detect the flutter of a single electron's spin. They're discovering that the magnetic realm extends far beyond what we've explored tonight, reaching into dimensions of physics where the familiar rules bend and twist like field lines in a solar storm. Quantum magnetism, they call it, where particles can exist in multiple magnetic states simultaneously, where the very act of observation changes what we observe. Consider for a moment the extraordinary possibility that magnetism itself might be evolving. Just as life has learned to sense and use magnetic fields over millions of years, the magnetic field may be responding to life in ways we're only beginning to suspect. Some researchers propose that the collective electrical activity of all living things on Earth might subtly influence our planet's magnetic behavior, creating a feedback loop between biosphere and magnetosphere that spans geological time. The aurora, those dancing curtains of light that have inspired countless generations, may hold keys to technologies we can barely imagine. Scientists are learning to read the electromagnetic signatures of these celestial displays like a cosmic language, decoding messages about space weather that could affect everything from satellite communications to power grids. In the future, we might predict magnetic storms with the same precision we now forecast hurricanes, protecting our technological civilization from the invisible tempests that rage through space. Deep beneath the ocean floors, researchers have discovered magnetic anomalies that suggest our planet's magnetic history is far more complex than we realized. Bands of magnetized rock record not just the reversals we knew about, but subtle variations that hint at multiple magnetic poles, wandering field lines, and periods when Earth's magnetic personality was utterly unlike anything we see today. These discoveries are rewriting the story of how planets generate and maintain their magnetic fields. The search for magnetic life continues to yield surprises. Scientists have found magnetotactic bacteria in environments so extreme they challenge our understanding of where life can exist. Some of these organisms create magnetic crystals with properties that exceed our best artificial magnets, suggesting that evolution has discovered magnetic principles we haven't yet learned. Studying these biological magnets might lead to entirely new materials that could revolutionize everything from data storage to medical imaging. Space exploration is revealing that magnetism plays a role in planetary formation itself. Young stars surrounded by disks of gas and dust use magnetic fields to channel material inward, feeding their growth while simultaneously launching powerful jets of matter back into space. The magnetic forces that shape our daily lives on Earth may have been instrumental in creating the solar system itself, invisible architects working on scales we're only now beginning to appreciate. The possibility of magnetic life existing on other worlds has captured the imagination of astrobiologists. If organisms on Earth can navigate using magnetic fields, might similar creatures exist on planets orbiting distant stars? Some researchers propose that magnetic biosignatures could be detectable across interstellar distances, offering a new way to search for life in the cosmos. The magnetic sense that guides earthly migrations might someday help us discover our cosmic neighbors. Climate scientists are uncovering connections between Earth's magnetic fields and long term climate patterns that operate on timescales of thousands or millions of years. Changes in magnetic field strength appear to correlate with ice ages, extinction events, and major shifts in atmospheric composition. The magnetic shield that protects us from space radiation also influences how cosmic rays interact with our atmosphere, potentially affecting cloud formation and global temperatures in ways we're still trying to understand. The development of room temperature superconductors remains one of the most tantalizing goals in magnetic research. Success would transform human civilization as dramatically as the discovery of fire or the invention of agriculture. Power lines that never lose energy, computers that never generate heat, vehicles that float silently above magnetic highways. These possibilities shimmer just beyond our current technological reach, like aurora on the horizon of human capability. Magnetic medicine continues to evolve in directions that seem almost magical. Researchers are developing magnetic nanoparticles that can be guided through the bloodstream to deliver drugs precisely where they're needed. Magnetic fields are being used to stimulate healing, treat depression, and even enhance memory formation. The same force that guides migrating birds might someday guide microscopic healers through our bodies, repairing damage at the cellular level. The study of magnetic consciousness represents perhaps the most intriguing frontier of all. Some researchers suggest that the magnetic fields generated by neural activity might play a role in consciousness itself, that the electromagnetic patterns in our brains might be more than just byproducts of thinking, but active participants in the process of awareness. If true, consciousness might be fundamentally electromagnetic, making us all participants in Earth's vast magnetic symphony. Artificial magnetic life forms exist only in the realm of speculation, but scientists are beginning to explore how magnetic fields might organize matter in ways that mimic biological processes. Self organizing magnetic systems could potentially repair themselves, evolve, and even reproduce, blurring the line between living and non living matter. The magnetic principles that guide bacteria might someday guide artificial organisms designed to clean polluted environments or explore hostile worlds. The magnetic future extends far beyond our planet. Interstellar travel might depend on magnetic sails that catch the solar wind like ancient mariners caught ocean breezes. Magnetic shields could protect spacecraft and their crews from the radiation that fills the space between stars. The same magnetic principles that create Earth's protective magnetosphere might someday create artificial magnetic bubbles around human settlements on other worlds. Perhaps most remarkably, we're beginning to understand that magnetism connects scales of existence from the quantum to the cosmic. The magnetic moment of a single electron is related to the magnetic field of an entire galaxy through principles we're still discovering. Every magnetic measurement we make, from the orientation of a compass needle to the detection of exoplanet magnetic fields, adds another note to a cosmic magnetic symphony that spans the entire universe. As we contemplate these future possibilities, we're reminded that the magnetic forces shaping our world operate on timescales that dwarf human experience. The dynamo in Earth's core has been spinning for over 4 billion years and will continue long after human civilization has become a distant memory. Yet in our brief moment of existence, we've learned to partner with these ancient forces, to read their signatures, and to harness their power for purposes both practical and profound. The invisible threads of magnetism that weave through every aspect of our existence connect us not just to our planet, but to the broader electromagnetic tapestry of the cosmos. Every magnetic field we study, every magnetic technology we develop, every magnetic mystery we solve brings us closer to understanding our place in a universe where invisible forces shape visible reality in ways both subtle and spectacular. The whispers of science continue to murmur their secrets, and there are always more wonders waiting in the gentle darkness of discovery, more reasons to marvel at the elegant complexity of the magnetic universe we call home. The story of magnetism wouldn't be complete without acknowledging the quiet revolution happening in our pockets and on our desks, where magnetic storage has become the invisible librarian of human memory. Every photograph you've saved, every song that moves you, every document that matters exists as tiny magnetic domains on spinning disks, each one a microscopic north or south pole holding a fragment of your digital life. Modern hard drives contain billions of these magnetic bits, each smaller than a virus, arranged in precise tracks that spiral inward like a metallic fingerprint. As the disk spins at thousands of revolutions per minute, a delicate arm dances across its surface, reading and writing magnetic patterns with accuracy that would astound the ancient navigators who first discovered lodestone. In a single second, this magnetic choreography can access more information than entire libraries once contained, but the magnetic storage story extends far beyond spinning disks. Magnetic tape, that humble descendant of the wire recorders from decades past, still serves as the backbone for preserving humanity's most precious digital treasures. In climate controlled vaults around the world, magnetic tapes store everything from national archives to the raw data that reveals the universe's deepest secrets. These unassuming ribbons of magnetized material can preserve information for decades, serving as the patient guardians of human knowledge. The development of magnetic sensors has reached extraordinary levels of sensitivity. Devices that can detect magnetic fields billions of times weaker than Earth's own. These quantum magnetometers operate at the very edge of physical possibility, where the magnetic signature of a single atom becomes measurable. In medical applications, they can detect the faint magnetic fields generated by the human heart and brain, revealing the electromagnetic patterns that accompany every thought and heartbeat. Magnetic resonance imaging represents perhaps the most elegant marriage of magnetism and medicine. When you lie inside an MRI scanner, you're surrounded by magnetic fields tens of thousands of times stronger than Earth's, fields so powerful they can align the nuclear spins of hydrogen atoms in your body. Radio waves then tickle these aligned atoms, causing them to emit their own radio signals that reveal the soft tissues within you with exquisite detail. It's as if magnetism has learned to paint portraits of the invisible interior landscape of living beings. The emergence of spintronics has opened entirely new chapters in magnetic technology. Unlike conventional electronics, which uses the charge of electrons, spintronic devices harness the magnetic spin of electrons themselves. This approach promises computers that consume far less power while operating much faster, memory that never forgets, even when power is removed, and logic devices that can process information in ways that seem almost biological in their efficiency. Magnetic levitation continues to capture human imagination, and for good reason. When superconducting materials are cooled to extraordinary temperatures, they can trap magnetic fields in ways that seem to defy gravity itself. Objects float in midair, held aloft by invisible magnetic forces that push and pull with perfect balance. Maglev trains glide above their tracks at hundreds of kilometers per hour, suspended in a magnetic embrace that eliminates friction and noise. The study of magnetic materials has revealed substances with properties that border on the magical. Some materials become magnetic only when cooled to specific temperatures. Others lose their magnetism when heated, and still others can switch their magnetic properties when exposed to light or pressure. These shape memory magnetic alloys remember their magnetic state like metallic mines, returning to previous configurations when triggered by temperature or field changes. Magnetic nanoparticles represent a frontier where magnetism meets medicine in increasingly sophisticated ways. These microscopic magnets can be designed to seek out specific types of cells, carrying therapeutic drugs directly to tumors or sites of infection. Guided by external magnetic fields, they navigate through the bloodstream like tiny submarines, delivering their healing cargo with precision that minimizes side effects and maximizes therapeutic benefit. The magnetic properties of ferrofluids create substances that seem alive, liquids studded with magnetic nanoparticles that respond to magnetic fields by forming spikes, valleys, and flowing patterns that dance in response to invisible forces. These materials find applications in everything from loudspeakers to spacecraft attitude control, demonstrating how magnetism can blur the boundaries between liquid and solid, between controlled and chaotic. Earth's magnetic field continues to surprise researchers with its complexity and variability. The South Atlantic anomaly, a region where the magnetic field is significantly weaker, allows more cosmic radiation to reach Earth's surface and poses challenges for satellites passing through the area. This magnetic weak spot appears to be growing and moving, offering clues about the dynamic processes occurring deep within our planet's core. The interaction between solar activity and Earth's magnetosphere creates space weather that can have profound effects on our technological civilization. During severe magnetic storms, induced electrical currents can flow through power lines, potentially causing blackouts that affect millions of people. Satellite communications can be disrupted, GPS accuracy can degrade, and even pipelines can experience corrosion from the electrical currents induced by changing magnetic fields. Magnetic archaeology has emerged as a powerful tool for understanding human history. Buried artifacts and ancient structures often create subtle magnetic anomalies that can be detected without excavation. Magnetometers towed behind aircraft can map entire archaeological sites, revealing the magnetic signatures of hearths, walls, and metallic objects that lie hidden beneath centuries of accumulated soil. The connection between magnetism and consciousness remains one of the most intriguing frontiers in neuroscience. Transcranial magnetic stimulation uses powerful magnetic pulses to temporarily alter brain activity in specific regions, allowing researchers to explore the relationship between neural activity and mental processes. These magnetic interventions can enhance memory, alter perception, and even influence decision making, suggesting that consciousness itself might be more electromagnetic than we previously realized. Magnetic metamaterials engineered at the nanoscale can manipulate magnetic fields in ways that don't occur naturally. These artificial structures can bend magnetic field lines around objects, potentially creating magnetic cloaking devices that could hide objects from magnetic detection. The same principles might eventually lead to magnetic lenses that can focus magnetic fields with the same precision that optical lenses focus light. The search for magnetic monopoles, hypothetical particles that would have only north or south magnetic polarity, continues to intrigue physicists. While every magnet we've ever encountered has both north and south poles, some theories suggest that magnetic monopoles could exist under extreme conditions. Their discovery would revolutionize our understanding of magnetism and might lead to entirely new forms of magnetic technology. Biomagnetic materials continue to evolve in directions that seem almost science fictional. Researchers are developing magnetic hydrogels that can change shape in response to magnetic fields, potentially leading to artificial muscles that could be controlled remotely. Magnetic scaffolds guide the growth of new tissue in regenerative medicine, while magnetic contrast agents make internal organs visible to medical imaging with unprecedented clarity. The magnetic signatures of distant galaxies provide windows into cosmic processes operating on scales almost too vast to comprehend. Spiral galaxies like our own Milky Way maintain magnetic fields that extend across hundreds of thousands of light years, generated by processes similar to those that create Earth's field but operating on galactic scales. These cosmic magnetic fields influence star formation, guide the flow of interstellar gas, and may play crucial roles in the evolution of galaxies themselves. Magnetic field therapy, while still controversial in some applications, continues to show promise for treating certain medical conditions. Pulsed electromagnetic fields appear to accelerate bone healing, reduce inflammation, and provide pain relief for some patients. The mechanisms remain partly mysterious, but the effects suggest that our bodies are more responsive to magnetic influences than we might expect. The development of magnetic refrigeration offers an environmentally friendly alternative to conventional cooling systems. Certain materials heat up when magnetized and cool down when demagnetized, allowing for cooling systems that use magnetic fields instead of chemical refrigerants. This technology could eventually replace the refrigerators and air conditioners that currently rely on substances that can harm the ozone layer. Magnetic sensing in wildlife continues to reveal new layers of complexity in animal navigation systems. Some animals appear to have magnetic maps so detailed they can detect the magnetic signatures of specific geographical features, allowing them to navigate with precision that rivals our best technological systems. These biological magnetic sensors operate with sensitivity that approaches the theoretical limits of what's physically possible. The magnetic future stretches out before us like an unexplored continent filled with possibilities we're only beginning to imagine. Quantum magnetic sensors might eventually detect the magnetic fields of individual molecules. Revolutionary materials could store information in magnetic domains smaller than atoms, and magnetic control systems might manipulate matter at the quantum level with precision that seems almost magical. As our gentle exploration of planetary magnetism continues to unfold, we find ourselves surrounded by invisible forces that connect the smallest scales of existence to the largest, from the quantum spin of electrons to the galactic magnetic fields that span light years. Every magnetic phenomenon we encounter, every magnetic technology we develop, every magnetic mystery we unravel, adds another thread to the vast tapestry of forces that weave through our universe. The whispers of science grow softer now as we prepare to drift deeper into the magnetic mysteries that surround us. But the story continues to evolve, connecting past discoveries to future possibilities in ways that remind us how much wonder still awaits in the gentle darkness of the unknown. Tomorrow brings new magnetic horizons to explore, new connections to discover between the invisible forces that shape our world and the visible wonders they create. Sleep peacefully tonight, knowing that you rest within the embrace of forces both ancient and eternal, guided by the same invisible threads that have woven through the story of our planet since its very beginning. The magnetic universe continues its patient work, spinning stories in languages of force and field that we're only just learning to read, but that speak to the deepest connections between matter and energy, between Earth and cosmos, between the seen and the unseen. And so, dear listener, we find ourselves at the gentle end of our journey through the invisible realm of planetary magnetism, having traced the delicate threads that connect Earth's molten heart to the farthest reaches of space, from the quantum dance of electrons to the cosmic choreography of galaxies spinning in the dark. We began tonight by wondering about the unseen forces that shape our world, and we discovered that magnetism is far more than just the curiosity that makes compass needles point north. It's the invisible sculptor that has been carving the story of our planet for billions of years, the silent guardian that shields us from cosmic radiation, the ancient navigator that guides creatures across vast distances, and the faithful servant that powers our modern civilization. In the swirling depths of Earth's core, we found liquid iron spinning its eternal dance, generating the dynamo that creates our protective magnetic bubble. We watched as this field reaches out into space, wrestling with the solar wind to create the magnetosphere where aurora paint the polar skies in curtains of ethereal light. We marveled at the countless creatures that have learned to read this magnetic script, following invisible highways across oceans and continents with precision that humbles our finest instruments. We traced humanity's growing partnership with these forces, from the first compass stones that guided ancient mariners to the quantum magnetometers that can detect the whisper of a single atom's magnetic moment. We saw how magnetic storage preserves our digital memories, how magnetic resonance imaging reveals the hidden landscapes within our bodies, and how magnetic levitation promises to transform transportation in ways that seem to defy the very gravity that holds us to Earth. Throughout this quiet exploration, we've discovered that magnetism is ultimately about connection, the invisible threads that link the microscopic to the cosmic, the ancient to the modern, the earthly to the celestial. Every magnetic field line we've followed has led us to deeper mysteries, greater wonders, more reasons to pause in appreciation of the elegant complexity that surrounds us. The magnetic field that cradles our planet will continue its patient work long after we've drifted into sleep, spinning its protective web around our world, guiding the migration of creatures through the darkness, and holding steady the invisible architecture that makes life possible. It operates on timescales that dwarf human existence, yet it touches every moment of our lives in ways both subtle and profound. As you settle into rest tonight, remember that you're not simply lying on the surface of a spinning rock in space. You're nestled within a vast magnetic embrace that extends far beyond the atmosphere, wrapped in invisible forces that have been your constant companions since the moment you were born. The same field that guides compass needles also influences the rhythm of your heartbeat, the electrical patterns in your brain, and the quantum processes that make consciousness itself possible. If this gentle journey through the realm of planetary magnetism has brought you a moment of wonder or peace, I'd be ever so grateful if you shared it with someone who might need their own quiet encounter with the invisible forces that make our world so remarkably, beautifully complex. Perhaps they too will find comfort in knowing that we live surrounded by ancient protections, guided by invisible wisdom, and connected to the cosmos by threads of force that sing in frequencies only the universe can hear. The whispers of science grow ever softer now, but before we drift into the peaceful darkness, let us pause to consider one final marvel that brings our magnetic journey full circle. You see, the same invisible forces we've explored tonight are at this very moment writing the next chapter of Earth's story, and perhaps, just perhaps, we are beginning to learn how to read that chapter before it's finished. Deep within Earth's core, the ancient dynamo continues its patient work, but it's not merely repeating the same magnetic melody it has sung for billions of years. Like a cosmic musician improvising on an eternal theme, our planet's magnetic field is constantly composing new variations, subtle changes that speak of the dynamic heart beating beneath our feet. The magnetic North Pole, that faithful companion of explorers, has been wandering more quickly in recent decades, drifting across the Canadian Arctic at an accelerating pace that suggests something profound is stirring in the depths below. Scientists monitoring these changes have discovered that our magnetic field isn't simply weakening uniformly, as one might expect from a slowly cooling planet. Instead, it's developing a complex personality with regions of strength and weakness that shift and evolve like weather patterns in the deep earth. The South Atlantic anomaly, that curious weak spot in our magnetic shield, has been growing and dividing, creating multiple regions where space radiation can more easily reach our atmosphere. It's as if the Earth is experimenting with new magnetic configurations, trying on different magnetic personalities to see which one fits best. These changes aren't cause for alarm, but rather invitations to wonder. They remind us that our planet is not a static sphere of rock and metal, but a living, breathing world whose magnetic heartbeat reflects the ongoing dance of forces we can barely imagine. The same processes that created the magnetic field in the first place continue to sculpt and reshape it, ensuring that Earth's magnetic story will never truly end, only evolve into new chapters we haven't yet learned to read. Perhaps most remarkably, we're beginning to realize that this magnetic evolution might be influenced by factors we never suspected. The ice ages that have periodically gripped our planet may have left their mark on the magnetic field through changes in how mass is distributed across Earth's surface. The slow drift of continents, the rise and fall of mountain ranges, even the circulation patterns of our oceans may all whisper suggestions to the dynamo far below, gently nudging it toward new magnetic configurations. And what of life itself? Could the billions of creatures that navigate by magnetism, from the smallest bacteria to the largest whales, be participants in a feedback loop we're only now beginning to glimpse? As evolution has fine tuned their magnetic senses over millions of years, might they in turn be influencing the very field they depend upon? It's a tantalizing possibility that the magnetic field and the life it protects might be partners in a dance far more intimate than we ever imagined. As we drift toward the close of our magnetic reverie, there's something wonderfully poetic about the way these invisible forces have woven themselves into the very fabric of human culture and imagination. Long before we understood the science behind Earth's magnetic embrace, our ancestors sensed its presence in ways that transcended mere navigation. They felt it in their bones, saw it dancing in the northern lights, and heard it whispering in the way iron sang to lodestone. The magnetic field has been humanity's silent teacher, patiently showing us that the universe operates according to principles far grander than what our eyes can see. Every time an ancient mariner trusted their compass to guide them across uncharted waters, they were placing their faith in forces that connected them to the spinning heart of the world. Every time indigenous peoples looked up at the aurora and saw the spirits of their ancestors dancing in the sky, they were witnessing the visible manifestation of invisible protection that has sheltered all life for eons. In a sense, our growing understanding of magnetism represents one of humanity's greatest achievements in learning to listen to the quiet language of the cosmos. We've discovered that the universe speaks not just in the roar of thunder or the brilliance of stars, but in the gentle whisper of magnetic field lines that curve through space like cosmic calligraphy, writing messages we're still learning to decode. Tonight, as satellites drift silently overhead, their instruments measuring the subtle fluctuations in Earth's magnetic personality, they're gathering data that will help us understand not just our own world, but the magnetic nature of planets orbiting distant stars. The same principles that create the aurora above your head might someday reveal the presence of aurora on worlds light years away, flickering beacons that could signal the presence of magnetic fields, atmospheres, and perhaps even life itself. The children being born tonight will grow up in a world where magnetic technologies we can barely imagine today will be as commonplace as smartphones are now. They might receive medical treatments delivered by magnetically guided nanobots, travel on vehicles that float effortlessly above magnetic highways, or even communicate through quantum networks that harness the magnetic properties of individual atoms. Yet for all these marvels, the most profound magic will remain the same ancient forces that have cradled our world since its birth. As the whispers of science grow fainter and sleep begins to call, remember that you are part of this grand magnetic story. Every heartbeat creates its own tiny magnetic field. Every thought generates electrical currents that contribute to the electromagnetic symphony of your brain. You are not merely surrounded by magnetic forces, you are a magnetic being, a creature of electricity and magnetism, living within the protective embrace of a magnetic planet, drifting through a magnetic cosmos. The aurora will continue their ancient dance long after we've closed our eyes, painting the polar skies with colors that have no names. Migrating birds will follow their magnetic highways through the darkness, guided by senses we're only beginning to understand. The great dynamo in Earth's core will continue its patient work, spinning liquid iron into the invisible threads that hold our world together. And somewhere in the vast reaches of space, other worlds with their own magnetic fields might be sheltering their own forms of life. Creatures that have learned to read the magnetic signatures of their own planets, following magnetic highways we'll never see but can imagine with wonder. Sleep well, dear traveler, knowing that you rest within layers upon layers of invisible protection, wrapped in magnetic forces that connect you to the very foundations of existence. The magnetic universe continues its quiet work while you dream, spinning stories in languages of force and field that speak to something deeper than knowledge, something closer to poetry. Tomorrow, when you wake and perhaps catch the first rays of sunlight streaming through your window, you might pause to consider that even those photons of light are electromagnetic waves, cousins to the magnetic fields we've explored tonight. The same fundamental forces that create Earth's protective magnetosphere also bring us the warmth and illumination that makes life possible. Light and magnetism, seemingly so different, are merely different expressions of the same cosmic song. And in that morning light, you might notice something you've seen countless times before, but perhaps never truly appreciated: the way iron filings scattered around a magnet arrange themselves in perfect curves, creating visible maps of invisible forces. These simple patterns, which children discover with wonder in school science classes, mirror the grand architecture of our magnetosphere, the spiral arms of galaxies, and the field lines that connect distant stars. The universe, it seems, has a deep fondness for elegant geometry, writing the same mathematical poetry from the smallest scales to the largest. The magnetic story we've shared tonight is still being written, not just by scientists in laboratories or by the slow dance of liquid iron in Earth's core, but by every creature that has ever followed a magnetic sense home, by every aurora that has ever painted the sky, by every compass that has ever pointed toward magnetic north. We are all co authors in this continuing narrative, participants in a planetary experiment that has been running for billions of years and shows no signs of ending. As our gentle exploration draws to its natural close, we're left with perhaps the most beautiful realization of all, that the invisible forces which shape our world are not cold, mechanical processes operating in isolation, but part of an interconnected web of relationships that includes every atom, every organism, every thought and dream. The magnetism that guides a migrating whale across the Pacific is connected to the magnetism that stores the memory of your first laugh on a computer hard drive, which is connected to the magnetism that shields us all from cosmic radiation. In this vast magnetic tapestry, nothing exists in isolation. Every magnetic field line that curves through space connects something to something else, creating a universe where separation is an illusion and connection is the deeper truth. The magnetic field that surrounds you as you drift toward sleep is the same field that surrounds the International Space Station orbiting overhead, the same field that reaches out to touch the solar wind streaming from our star. Perhaps that's the most profound whisper of science we can carry with us into our dreams. That we live in a universe designed for connection, where invisible threads of force weave everything together in patterns of extraordinary beauty and complexity. The magnetic fields that shape our planet also shape our understanding of what it means to be part of something infinitely larger than ourselves. And so, dear listener, as we reach this quiet moment where our magnetic journey naturally concludes, I find myself thinking about the extraordinary privilege we've shared tonight, peering behind the veil of the visible world to glimpse the elegant machinery that keeps our planet humming with life. We've traveled together from the microscopic compass needles in bacterial cells to the vast magnetic highways that span our solar system, and in doing so, we've discovered something profound about the nature of reality itself. The invisible isn't absent, it's simply patient, waiting for the right instruments and the right questions to reveal its secrets. The magnetic fields we've explored tonight have been there all along, quietly doing their work while we went about our daily lives, as faithful and constant as the sunrise. There's something deeply comforting in knowing that these ancient forces continue their vigil even as we sleep, that the same magnetic embrace that protected the first stirrings of life in primordial oceans still cradles us today. Whether we understand them or not, whether we notice them or not, they persist in their gentle guardianship, asking nothing in return except perhaps our wonder when we finally pause to listen to their whispers. If tonight's exploration has kindled even the smallest spark of curiosity about the invisible architecture that surrounds us, then perhaps you'll find yourself noticing magnetic phenomena in unexpected places. The way your refrigerator door closes with that satisfying snap, the gentle hum of the electric motor in your kitchen appliance, even the compass app on your phone, all become small windows into the grand magnetic story we've shared. The whispers of science never truly end. They simply change pitch and tone, revealing new melodies in the cosmic symphony that plays all around us. Our magnetic field is but one instrument in this vast orchestra, harmonizing with gravitational waves from distant black holes, with the nuclear fusion fires of stars, with the quantum fluctuations that bubble up from the very foam of space-time itself. As you close your eyes tonight and feel yourself drifting toward sleep, know that you carry within you the same electromagnetic patterns that dance through the aurora, the same fundamental forces that bind atoms together and hold galaxies apart. You are not separate from the magnetic universe we've explored. You are part of it, woven into its fabric as surely as iron is woven into the core of our world. Sleep peacefully in the knowledge that tomorrow will bring new discoveries, new questions, and new reasons to marvel at the quiet complexity of existence. And perhaps, in your dreams, you might find yourself floating along those invisible field lines we've traced tonight, carried by currents of force that connect every corner of creation in one magnificent, unending embrace. The magnetic universe continues its ancient work, spinning dreams in languages older than words. And you, dear traveler, are part of that dream. Sweet rest, and thank you for sharing this gentle journey through the whispers of planetary magnetism.